so today we want to look at functions and focus on finding the turning point, the intercepts, as well as sketching the graph. So to do that, since we've already done this topic in pure mathematics, so what we are now just going to be doing today is mainly focusing on the range and also practicing completing the square method. And if you're not pretty sure with completing the square, you can scroll down my videos and look at completing the square. So let's look at this one question here. So we've got a question where a function f of x is x squared plus 2x minus 3. And we are asked to first sketch the graph, given the coordinates of the turning point where the graph intercepts, where the graph cuts the y-axis and the x-axis, as well as the turning point. Now, just to start with, from P1, we know that in order to know the x-intercepts of the function, f of x must be equal to 0. So we must solve the graph f of x equals to 0. So we must solve the equation f of x equals to 0. So our f of x in this case is x squared plus 2x minus 3 equals to 0. So what we are going to do then is to try and solve this. So you can solve this using the quadratic equation or by factorization. So in this case, I know that this can be solved by factorization. And if I solve it by factorization, I'm looking for two numbers that can give me negative 3 if I multiply them, and if I add them, I get 2, since the coefficient of x squared is 1. And those two numbers are actually, to get negative 3, I can multiply 3 and negative 1. When I add these two, I'm going to get a 2. So right away, it simply means that x squared should be plus 3x minus 1x minus 3 equals to 0, which if we factorize this, we are going to get x plus 3, then negative 1, x plus 3 equals to 0, which then implies x is equal to x minus 1, and then x plus 3 equals to 0, implying that x is equal to 1 or x is equal to negative 3. So these are the 2 points, x equals to 1 and negative 3, where the graph of this quadratic equation cuts the x-axis. So we've got two things now. And once we get these two things, we must also now look at what's our y-intercept. Now, from P Mathematics 1, we know that the constant term is actually our y-intercept. So our y-intercept is simply y equals negative 3. Okay, so we know that the graph is cutting the x-axis there, and that y equals to negative 3. Okay, so now before we even get to the graph, we must again now look at the last part of the question, the turning point. Now, when we did IGCSE mathematics, we did say to find the turning point of a quadratic equation, we must be able to do completing the square. And in order to find the turning point, we must be able to complete the square, the given quadratic equation. And those of you who've forgotten completing the square method, you can scroll down or up, I don't know, whichever, to watch what completing the square is. So to complete the square, we are going to do x, then we find half of this guy, which is 2, plus 1 squared. Now, because we've added a 1, we are going to subtract it. We've added the 1 squared, then minus 3 as it is equals to 0. So in this case, we have x plus 1 squared minus 4 equals to 0. So this 1 squared minus 3 gives us 4. Now, the turning point, this is the value of y at the turning point. And when we solve this guy here equals to 0, we get the value of x at the turning point. So to do that now, simply means we are going to do x plus 1 equals to 0, which implies that x is negative 1, and y is negative 4 at the turning point. So we've got the turning point, we've got the x-intercepts and the y-intercept. So to answer the question of sketch, then we can sketch. So to sketch means you're not exact, you're just giving rough ideas. So the answer to this would then be, if I can try to do my own sketch here, you do that and that. So this is negative 3 here, and then here is the x-axis, there is our y-axis, and then negative 1 comma negative 4. So let's say negative 1, so we're going to say, let's say negative 4 is here, let's point negative 4. So negative 1, let's say negative 1 is here, so possibly the turning point is there. This is our x-intercept, and then remember that our x-intercept for the positive value is 1, so possibly let's say this is 1, okay, and then it cuts the y-axis at negative 3, so let's have that as negative 3, and our graph will just smoothly pass through here at the turning point there, then it goes up through the y-intercept and up like that. So these two values here are this one here and that one. These are the two values here, the x-intercept, this is the constant, and this is our turning point. So if you look at the things that we've done, we've looked at solving the quadratic equation and then completing the square to find the turning point, and also using the constant term to tell us where the graph cuts the x or the y axis. Now, just before we look at another question, when we complete the square, we get the equation as it is here, okay? If we were asked to find the range of this function, the range is, you can see that this graph starts from the line negative 4 and it shoots up like that. So if we were asked to state the range of this function, we would have said the function would be f of x greater or equal to negative 4, because it starts at negative 4 here and then it shoots up like that. So you will see in some other questions that we're going to look at. So let's look at some other questions and see what we are going to have. Okay, so we've got this second question here, where they say the function f of x is defined as that, work out the range, okay? So now in this case, they just want to do the range. Now they've told us that the domain is everything 0 going up. So we are now restricted here, so meaning the input values, okay, the input values start from 0, 1, and so on and so forth, going into the positive direction. Now, to find the range, we are simply saying what would be the minimum value that this function can attain, given that we start with x equals to 0. So if you are given actually a domain, it's much easier to find the range than when the domain is open. So work out the range. So to work out the range here, we're just going to say, okay, we are going to try f of 0, since 0 is the least number in this our domain. So it means you're going to have 0 squared minus 4, and it gives you negative 4. You can then see that if you were to replace other bigger numbers than 0 for x, this is the minimum value you can get. If you try 1, you'll get this as negative 3, but the minimum is this. So therefore, we can conclude here to say the range is simply equal to f of x being greater or equal to negative 4. That's what it means. So that was a 2-mark question. Now let us look at B. If the domain of f of x is changed to x being less or equal to 0, what is the range of f of x? So this question is actually a very simple question. So now they are changing the numbers to say, if you were to start from 0 and you kept going negative 1, negative 2, negative 3, negative 4, and so on and so forth into the negative direction, what would be the minimum value of f of x that you can get? So now for this one, we need to show a far much greater understanding of what substitution is. Like in this case, we've got x squared. Now remember, because our f of x is equal to x squared minus 4, it means when we replace any negative value where there is x, the outcome is going to be positive, because when we square a negative number, we get a positive number. So if you think about it very well, we can also think and say, okay, let's just try numbers, since we just want to try numbers. So we're going to say 0 squared minus 4 would give us negative 4. Then you try negative 1 squared. I put it in brackets here. It will give you 1 minus that to give you negative 3. If you try, let's say things like negative 2 squared will give you, negative 2 squared is going to give you 4, and then 4 minus 4, it will give you 0. So you can see that as we go down on the negative values, the numbers keep getting bigger, which is the output for f of x. So it simply means, again, negative 4 is the least value. So even though they've said we change the domain going in the negative, but the range would still be f of x greater or equal to negative 4. This is a very nice case because x is squared. It will not be different with the x being greater or equal to 0, because everything that is negative, this function is turning them into positive. So the range for this first case and the second case are just the same, simply because of this x squared here. It makes all negative substitution be the same as the equivalent positive numbers. So let's look at another example and see. Okay, so let's look at the last example here, which is a very nice, easy question. So they've given us the function f of x and g of x are defined by that. F of x equals to x squared, where x, which is the domain, is a member of real numbers, and g of x is equal to 4x minus 3, where x is real numbers. Write down the range of f of x. Remember, range is simply the output. Okay, it's just the output when we put the numbers from the domain. Now, when you look at f of x, okay, the f of x that is given, which is x squared, they're asking if you were to put all numbers, because real numbers means negative numbers and positive numbers, what would be the range? Now, because this is x squared, like we did in the previous example, it means no matter what sort of negative number we replace for x, the output will always be positive. But the least number, if we put 0 here, 0 will be 0. Everything else would be positive. You can try random things like, let's say, f of negative 10 if you want. This would just be the same as f of 10, because it would be negative 10 squared, which then gives you 100. The same as f of 10. So it simply means all negative values are not going to have an effect on the outcome, because they will all come out positive. Okay, so it simply means the range of this function will start at 0, because if we say f of 0, we get 0 squared, which is 0. So then it simply means that the range of this function here is simply f of x being greater or equal to 0, because it will all be positive. Okay, so it's important that we pay attention to the effect of certain powers, because some powers will restrict and change negatives into positives. It's very important that we pay attention to that. Now let's look at B, where it says find f of g of x. F of g of x, so meaning into our f function, which is x squared, where there is x, we are going to replace the g function. That's what that means. We've already looked at that. So if my x becomes g, it simply means my f of g of x becomes 4x minus 3 then squared. So we're just expanding this. This is just expansion of double brackets because we've got 4x minus 3, again 4x minus 3. So if we expand this, we've already done lots of expansion since form 1 and form 2. This will give you 16x squared and then minus 24x plus 9. This is our f of g of x. Now b, which is part 2, just the opposite. They say g of f of x, which means when we look at the g function, which is 4x minus 3, the x should become the f function, the f of x. So this will imply that it will become 4, where there is x, I'm putting the f function and then minus 3 like that. So this becomes 4x squared minus 3 like that. Okay, so this is just basic substitution. Now you can see, very simple, we've done this. Now the last part, they are saying solve the equation f of x. What's our f of x? F of x equals to g of x. Our f of x is x squared, but it must be equal to 4x minus 3. So they want us to solve this. We can just solve this using a quadratic equation by collecting everything onto one side to become this. The negative, once it's transposed, it becomes plus, and the positive becomes minus. You can see that we can actually factorize this. We've got numbers that we can multiply to give us 3, and if we add them we get negative 4, and those numbers actually for positive 3 are negative 3 and negative 1, which simply means our x squared would be minus 3x minus 1x plus 3 equals to 0. And if we factorize this by grouping, we get x minus 3, then minus 1, x minus 3 equals to that, which simply means x minus 1 in brackets and x minus 3 like that, which simply means x is equal to 1 or x is equal to 3. These are the solutions to the question. So thank you. You can see that functions are actually very nice. Now before I end the video, I just want to emphasize one concept that is very important on functions. I will just talk about it in a brief space. When you have functions and you are asked to do the range of a quadratic equation, it's something that is actually very, very simple. You just do completing the square, and the constant term is your range. What I'm talking about is, let's say we've been given f of x equals to x squared minus anything like 4x plus 9. They say find the range of this function. If I'm to find the range of this function here, where the domain is a member of real numbers, here means they are not restricting my domain that much. I just do completing the square of this function, which is x. Then I find half of this to give me half of negative 4 gives me negative 2, everything squared. Now I've done a negative 2 squared, but I must subtract it from my general equation like that. Then this gives me x minus 2 squared. This is going to give me negative 4 plus 9, which gives me 5. So this 5 here is actually your range of f of x. It simply means if you were to sketch this graph, f of x was actually going to be greater or equal to 5 in that case. Then if they asked for the turning point, this same 5 here is your y value at the turning point, y value at TP. then your x value is when you solve this guy equals to 0, which means x is equal to 2 at the turning point. So the turning point is simply 2, 5. Your range is f of x being greater or equal to 5. Then you can solve this equation to know the intercepts. It's very nice and very simple. So this is a concept that I did not over highlight in the examples that I gave, but very, very common. So thank you very much for your time, and keep in touch or get in touch in case of any questions or requests for a particular topic that we must drill. Looking forward to more practice questions with you. Thank you.